Hi, I am excited to share yet another thing, which is actually two things. This one and this one. Now this one is pretty, I guess one could say, straightforward for triangles. It's a chain of eyes, and as you can see, it's got two sides here, two edges, and each one of those has 6 fingers around it, which is to say that this has got 6 triangles pointing one way and 6 pointing the other, and both of those together amount to a dozen. So this is a dozen eyes, and as you can see, these are tensecrities. They are able to play and fold and form and move as they are. And I suppose, yeah, there's nice things to be found here that I haven't yet figured and played with. But you can see how I can turn this inside out. Alright? Now it's outside in, and inside out, and outside in, and all around. So in that sense, it's a torus. It has 2 sides to it. And I can either look from the outside in or look from the inside out, but it remains such. Now what happens if we increase the number of eyes by 1? So we get 1,001 eyes, which is also kind of like 12 and another one, which is 0, if you like. And with that we get this beautiful thing, which is what I actually did first before I did the other. And you might recognize this as a Moebius strip, because it's got a twist in it. Because the number of fingers is 1 over 12, so it's odd. This has the odd peculiar attribute of being one-sided in a way, because, well, it's got only one edge, which has 1,001 fingers, rather than 2 edges with 6 fingers each. And when I'm looking into this eye here, let's pick the one that is a little different, where there's a knot here. This one has the knot. So if this is our 0, and I'm looking into it right now, looking at you. Was meinst du? There was a little interruption here. Well, this is a curious thing now, because it's got... well, I was looking into the eye here, and in this case I'm looking through the eye, so that the knot is pointing that way. Alright. Now let's turn this thing around, and we're not gonna turn it in my fingers. I keep both sides of my hands. Oh, it's there already. There's the knot. But now I can look through the same eye without having turned it otherwise, and I'm looking through it the other way, because it's pointing, the knot is pointing that way. So let's keep going from here, and there it is again, the knot, and pointing that way. So we've done a full turn of this, and the whole system has turned inside out without me turning it, like inverting it like so, as I had to do with the other one, right? So bear in mind with this that when I'm saying inside out, in this case I'm speaking of the in-betweenness of this tunnel here, if you like, the inside of the loop, because I'm either looking into that from the convex side or I'm looking out of it from the concave side. And what I do here is I flip it inside out, and what was concave becomes convex. Now, with the same applied to this, we realize that this thing is well, how would we call that? Omnicave, concave and convex. Convex cave, concave wax, complex, whatever. But it is remarkable insofar that we can look through this from the convex into the concave, pointing that way, and the same when it returns on the other side here is pointing that way. So what is now its convex, looking at me, is actually the exact same side of it that it was before. But you see, this is not two-dimensional or it's not even three-dimensional. This is polydimensional, so to speak. It's spherical because these are actual bodies, and I'm not it's not like taking a strip of paper and thinking of it as a flat thing, saying it's two-dimensional, you know, taping that together and then basically ignoring the entire volume of the body of it. I mean, it's a little more complex to try to draw a line around this, which I guess would be possible, but since every member of this is allowed to spin on its own, this whole entire thing turns out that the actual loop is a synergetic effect. The Moebius loop is a synergetic effect because it is only possible because of the membership of all of these beats and the string and the universe, the whole of it, including me with my idea and my hands binding this so that it becomes a thing. It's a pleasure to play with, I can tell you. And I suppose it's got a wave in it, in a way. And I'm turning the wave around right now without really turning the band itself. So it's a torus with a twist. Odd, odd thing. And what I could also point out is this has a finger on one side here, and then symmetric to that it's got an eye on the other. Right, so if I twist this like so, then there is a plane in which or not a plane, but the eye on one side and the finger on the other, they move like so, right, in the same orientation, and they get closer together or further apart, but they don't necessarily twist like that. Whereas, remember on this one, the evenness of it has it so that I'm either holding on to single fingers, which are actually, it turns out, precessed. So this one here is that way and this one is that way. So in other words, this is basically like a stretched out four eyes, because in four eyes we have that kind of relationship as well. And those two precessed fingers are equal distance apart. Now I can also turn it so that it's got an eye on both sides, and that's also precessed. So there. And I suppose that we can twist this, yeah. And that might be somewhat relative to, akin to the tetrahelix as well. Well, that's it for now. Odd and even. I hope you enjoyed that as much as I did, and I invite you to take a look around at all the other stuff that I've been creating here and sharing, because it's easy and fun, and it's our own all together. Take care.